Hello student, welcome to my lecture video again. In this video, we have the lesson plan as followed. So we will be talking about and discussing the molar mass and molecular weight of compound. We will also talk about elemental analysis as well as percentage composition also for compound. And lastly, we'll be talking about converting the mass of a compound to moles to molecules, and molecules to atom. Actually, all these three topics that we are going to discuss, it has its roots in chapter 2 when we discussed about atomic weight, moles, and conversion of gram to moles to atoms in elements. When you move from elements to compounds, there are fundamental principles that we will follow, which are pretty similar to what we discussed in chapter 2. Just we have to modify, keeping in mind we are talking about a compound. And as you have already learned, compound is formed by chemical combination of atoms of different element. And a compound is represented by a formula. It's not like a symbol. In case of element, calcium is represented by Ca, but when it is a compound, it's a formula. For example, H2O, it is water. So we will discuss all these things with some examples or some numerical problems. So let's, go and try to see and what kind of problems we supposed to see. Let's look at from ECA. We will be talking about the molar mass or molecular the compounds like aluminum sulfate and lithium sulfate, as well as so look at it now. We will be first talking about how to find out the molar mass and molecular weight and what is the difference of these two. These two are very, I will say, close to one another, but we will differentiate. First, look at the compound we are talking about. This is a compound made up of magnesium, chlorine, and oxygen, and its name is magnesium chlorate. Since we have already discussed the naming of compound, you can understand it is a magnesium chloride. It is a compound between magnesium and polyatomic and chlorate. So it is magnesium. Actually, it is magnesium perchlorate. Okay. So it is an ionic compound because metal and non-metals are present in a sense. And we have to find out what is the difference between first the molar mass and molecular weight, and then we'll explain. So if a compound is there which is formed by the chemical bonding between atoms of different element, in this case it is magnesium, chlorine, and oxygen in this case. So first we have to find out the molecular weight. Molecular weight. How do you find out? You have to add the atomic weight of all the elements present. So if you look at it, this molecular weight of all the elements we will be adding together. How many magnesium atom is there? Only one. What is the atomic weight of magnesium? I will say 24.3 multiplied by 1. How many chlorine atom is there? Look at, there is only one, but there is a 2 here after the parenthesis. So it will be multiplied 1 into 2, so 2 chlorine atom. Chlorine is 35.5 multiplied by 2. Similar way, there are 4 oxygen atom and multiplied by 2, so 8 oxygen atom, it is 16 into 8. So if you add them together, that's what is going to give you the molecular weight of the compound. So it is 16 into 8, 16 into 8, it is 24.3 plus 71 plus 128. So if you add all of them, so it is 23.3. So this is called molecular weight. Does it have a unit? No. Molecular weight is simply I will tell you, the number. It has no unit. But when you talk about molar mass means how much substance is present in 1 mole. That is gram per moles. And it has the unit gram per mole. So molar mass refers what is the mass present in 1 mole. The way we have discussed in case of an element, what are the atomic weight, you convert into grams, that is 1 mole. Same thing here. Molar mass is nothing but how much substance is present in gram in 1 mole. And in this case, it is nothing but the molecular weight. So if you take the molecular weight, exactly it is going to tell you that is the molar mass of the substance. Same thing, you can do it here. It is aluminum acetate, the name of the compound. This is aluminum and this is acetate ion. So its name is aluminum acetate. This is acetate ion, polyatomic ion, and this is alumina. Again, it is an ionic compound. First, we will find out molecular weight. So in case of aluminum, how many aluminum is there? Only one. So it is alumina approximately 27. How many carbon? Carbon 2 into 3, 6. So it will be carbon 12 into 6. The atomic weight of carbon is 12. Oxygen, hydrogen is 9. So 1 into 9. Atomic weight of hydrogen is 1. Oxygen in 2 into 3, 6. So 16 into 6. So if you add them together, it will be coming approximately 204. Again, what is the molecular weight? This is the number. And what is the molar mass? It's 204. The atomic weight converted to gram per mole. And this is the answer. Okay. So this is the way you find out actually, in this case, the molecular weight and molar mass of a compound. Question number 41 is slightly different. They are asking the molecular weight of nitrous oxide. Actually, it is a compound between nitrogen and oxygen. So the molecular weight of nitrogen and oxygen react with each other and produce molecular compound because nitrogen is a non-metal, oxygen is a non-metal. When they combine, they produce a lot of compounds actually, starting with N2O, NO, N2O3, NO2, N2O5. So they are talking about laughing gas means this one in this case. So this is, you have to find out the molecular weight of this one is equal to what is called N2O, nitrogen 14 into 2 plus 16 into 1, 16 is to 1. So it will be 28 plus 16. So it is 44. Okay. So this is exactly the C44. Although I said, the atomic weight has no unit, but you have learned in case of the subatomic particles and like proton and neutrons, they are measured in terms of a relative unit called AMU. Sometimes, it is also appropriate to say this molecular weight can be expressed as AMU. That's a relative unit in a sense. So it is exactly 44. If you want, if you can add AMU, but without units, it's just, that is normally people work with like this one. So, the molecular weight of a laughing gas, which is nitrous oxide, N2O, is 44. Okay. So now you understand, how to find out the molecular weight or the molar mass. But in addition to that, one thing we need to know, whenever we find out a molecular weight or molar mass, the total mass is coming from the mass of the individual uh, atoms of the element. For example, in this compound, in question number 42, it is called Al2SO4 whole 3. It is made up of aluminum, sulfur, and oxygen. So in this case, they are asking what is calculate the mass percentage composition of sulfur or mass percent composition of sulfur. So whatever the total mass of the aluminum sulfate, the molecular weight, they came from individual contribution of aluminum, sulfur, and oxygen. They are trying to know what is the contribution of the sulfur individual. So how much is the percentage contribution of sulfur towards the mass of the entire compound, and it is called aluminum sulfate. Again, it is a ionic compound between aluminum and polyatomic and sulfate. So in this aluminum sulfate, what is the contribution of sulfur? So what we will do, we will find out the molecular weight. So it will be aluminum 27 into 2 multiplied by 2, sulfur 1 into 3, sulfur is 32, atomic weight multiplied by 3, oxygen is 4 into 3, 12, this. So if you look at this one, the total molecular weight 342. You can also say 342 AME, but normally people just say 100. So what is the contribution of relatively by sulfur? This one. Actually, this is contributed by aluminum, this is by sulfur, and this one by oxygen. So what is the percentage of sulfur? So what is the percentage of sulfur? So you will take the mass of sulfur individually over 342 into 100. So if you do this one, it will come approximately 28.1%. This one is the answer. So you have calculated, if you take 100 grams of aluminum sulfate in mass, how much comes from sulfur? 28.1 grams. So similarly, you can find out the mass percentage of aluminum. Similarly, although it is not asked here, so it will be 27 into 2 over 342 into 100. Similarly, you can find out for oxygen. So oxygen will be 16 into 12 over 342 into 100. So if you calculate all of them and you look at it, how much it's going to come? 16 into 12 divided by 342. So it is around 56.1%. The percentage contribution of oxygen is this one. In case of aluminum, it is 27 into 2 divided by 342. So it is around 15.8%. So if you look at it, if you add all of them, the percentage of aluminum, sulfur, and oxygen, let's see how much it is. 15.8 plus 56.1 plus 28.1. So if you add all of them, the percentage of aluminum, percentage of sulfur, percentage of oxygen, it will be 100%. So in any compound, the contribution of the mass of individual elements present together will be equal to 100%. In this case, it is 2 aluminum, sulfur, and oxygen. If there are 3 elements, aluminum, sulfur, and oxygen. If there are 4 elements, doesn't matter. 5 elements or 2 elements. In all the cases, the percentage composition of uh, the elements in percentage will be equal to 100%. Actually, this data is very important. You will learn in the later section of this particular chapter that this data will help you to calculate called the empirical formula. So we will discuss that in a separate videos subsequently. So these elemental composition, how much contribution is coming from individual element, that really helps to find out the empirical formula and eventually the molecular formula. Okay. So calculate the others which are here. These are pretty simple problem in a sense, you know. So let me do 45 and that will help you to understand that what, for example, which of the following contain 39% of the carbon in a sense. So, you know, in each one of them, you have to find out the molecular weight and then see what is the contribution of carbon in this case, you know. So for example, I will take 2 of them. So you can do all of them. So I will say this one and this one. In case of a carbon, I will not calculate the everything, but I will tell you the molecular weight is like this. 12 into 1, because in carbon dioxide there is 1 carbon atom. There are 2 oxygen. So it will be 44. Out of this 44, what is contributed by carbon? It is 12. So percentage of carbon is 12 over 44 into 100. Similarly, you find out molecular weight of this compound. It has 1 carbon, 12 into 1. How many hydrogen? 3 into 2, 5. So you have to pull them together because 3 hydrogen is here, 2 hydrogen is here, 5. Plus 1 nitrogen. So 14 into 1. So it will be 12 plus 5 plus 14. How much it is? 12 plus 14 plus, so no, this one is, so it will be coming to, if you add 12 plus 5 plus 14, it is 31. So out of this 31, how much came from carbon? 12. The percentage carbon is here, 12 over 31 into 100. So if you look at it, it was approximately what is called 38.7%. So it is close to 39. So this is the correct answer. Okay. In this case, it is 39. But in case of a carbon dioxide, it is different. It will be 12 over 44 is 27.2%. So again, before I move on to the other part, this kind of calculation, which is called the elemental composition or calculating the individual contribution of the elements towards the total mass of the substance, and it is very useful to be utilized for what is called the empirical formula or molecular formula of the compound. The last part, you know, now we know molar mass and we know what is 1 mole in case of a compound, and then we will try to convert gram to mole, moles to molecules to the atoms or ions. So it needs a little more, I will say, discussion, and I will try to explain this in terms of or in comparison to whatever we learned in case of elements. Let's look at it. So we will learn how to convert conversion of units. Conversion of units. What you will do in case of an element you have already done, but still I will like to explain again so that you are. In case of element, we convert it to gram to moles and moles to number of atoms. Why? Elements are composed of atoms. Atom is the smallest part of the element which represent the properties of that element. If you break atoms and go to electron, proton, and neutron, then individual elements are gone. All electron, proton, and neutrons are same in terms of their characteristics, no matter which elements they are coming from. So in case of elements, our conversion was only two steps, gram to mole, moles to atoms. But in case of a compound, it is slightly more complicated or longer. So in case of a compound, we will convert gram to moles, moles to molecules. Why? Compounds are made up of molecules. For example, H2O. It is made up of hydrogen and oxygen, that's perfectly fine, but its base unit is the molecule, H2O. Yes, in that molecule, inside the molecule, you can count the number of hydrogen and oxygen atom, but nonetheless, H2O is the base unit which represents the property of water. So from molecule, you can go to atoms, or sometimes we can go to ions that we will explain with the example. So we have to know what to do, how to do it. The same way I did in case of element, I will give you that how to do it. So in this case, when you want to go from gram to moles, what you will do? Divide by molecular. Write it down carefully. Divide by the molecular weight. And if it is divide, opposite conversion will be multiplication. So multiply by molecular weight. Moles to molecule, same. 6.022 10 to the power 23. You multiply by, this will be dividing. So from molecules to atoms, what you will multiply by? So in this case, when you go from molecules to atom, so you will multiply by number of atoms. And in this case, you divide by number of atoms. Okay, so this thing you remind yourself and memorize it. So how do you go from gram to mole? Same, you divide by the molecular weight, and in case of elements, it was divide by the atomic weight. Why it is atomic weight? In case of elements, there is only one type of atom. That's why it is atomic weight. But in this case of a compound, when a compound is formed by chemical combination of the atoms, then it's become a molecule. So instead of atomic weight, it will be molecular weight. And the Avogadro's number is same. 1 mole of the substance always contain Avogadro's number of particles. As I explained previously, in case of an atom, it will be Avogadro's number of atoms. In case of a molecules, it will be Avogadro's number of molecules. So let me clarify one more time before we start solving problem. So if you look at the relationship between moles, grams, and Avogadro's number, this one is. In case of an element, 1 mole of the substance is equal to atomic weight gram of the substance. And it contains 6.022 10 to the power 23 atoms. But in case of a compound, the basic principle is same, but there is a little bit of extension. So 1 mole is equal to molecular weight gram of the substance. But in case of this is molecule, Avogadro's number of molecules. Okay, so this is very similar. Only thing is that in case of element, it is atomic weight and the base unit is atoms. In case of a compound, 1 mole is equal to molecular weight grams of the substance. But Avogadro's number is same. Only in case of a compound, this one will be molecules. Okay. And from molecules, if you want to go to atoms, just count the number of atoms per molecule and multiply it. So we will solve significant number of problems, but please memorize it and please try to understand how it is unique in terms of the calculation for elements and compounds. Their fundamentals are same, but there is a little bit of twist in terms of when it is atom, it is for element. When it is molecule, when it is in case of a compound. Okay. So let's try solving some specific problem. Let's look for question number 46. Okay. So if you look at it, in this case, they have given you formula units. You may be thinking, I didn't heard of this name even. So actually formula unit is nothing but what is called number of atoms, number of molecules. No, sorry. Formula units, or you can say molecules. So actually, as I already discussed in the previous slide, previous videos, compounds are two types. They are ionic and molecular. So in case of a molecular compound, molecules are fine. But in case of an ionic compound, sometimes there is a possibility the ionic compound dissociated into cations or anions once dissolved in water. That time, many people believe that it is better not to talk about molecule, rather formula units. So it is same concept. In case of an ionic compound, instead of telling them as a molecule, rather we say formula units, because ionic compound usually get dissociated into cations or anions when dissolved in water. For example, if you take sodium chloride and dissolve in water, you will find they dissociate into Na plus and Cl minus. So some people argue, if they dissociate into cations and anions, there is no existence of NaCl as such when they are dissolved in liquid water, in a sense. So that's why instead of saying molecule, rather say formula unit. The formula as it is. Okay. So it is a technical term, but in practical purpose, they are all same. So we have to convert to moles. So as per the diagram I have given to you, or technique, so how do you convert molecules, formula unit? How do you convert into moles? So 1 mole is equal to Avogadro's number, am I correct? 6.022 10 to the power 23 formula unit, because formula unit and molecule are same. So first you are trying to convert formula unit, you have to cancel. So it will be on the bottom. 10 to the power 23. And it is 1 mole. But the answer is millimoles. The way millimoles 10 to the power, minus 3 milli in a sense. But we are getting milli to, actually we will be converting from, this is mole to millimole. So 1 mole is equal to, then it will be the same factor, only it will be 10 to the power positive. Why? Mole is a bigger unit Mole is a bigger unit, so that's why the minus will be positive. The way we explained the SI unit chart, the factor which represents the prefixes. So when it will be positive, when it will be negative, depends on you are converting to small to big or big to small. If it is small to big, the 10 to the power minus will be the number, the exponent, but if it is big to small, then it will be positive. So it will be 1 mole is equal to 10 to the power plus 3 millimoles. So again, you have to write down the appropriate conversion factor. So if you write down, this is 1 mole. So look at it. This one cancel. And if you, oh sorry, this one I wrote it wrong. It will be 10 to the power 2. So if you calculate, this one will come around 79.4 millimole. Put it in calculator. This will be your answer D. Okay. Let's move on to question number 48. So what is your starting point? They have given in milligram and they are asking to calculate how many molecules are there, you know. So we have already told you how to do gram to moles and moles to molecules. But there is, in this case, he started with not gram, rather milligram. So first there will be another step before that. You have to convert milligrams to gram, then gram to mole to molecule. So if you look at it, 45.8 milligram of C2H4. So how do you convert milligram to gram? 1 milligram is equal to 10 to the power minus 1 gram is equal to 10 to the power minus 3 milligram. Okay. So you will write down milligram, you have to cancel. So it will be writing like this one, 10 to the power minus 3 milligram over 1 gram. So actually, I just misspoke. 1 gram is equal to 10 to the power plus 3 milligram because gram is bigger, milligram is smaller. So this one will be equal to 1 gram is equal to 10 to the power plus 3 milligram. 1 gram contain 1000 milligrams. So your 10 to the power 3 milligram will be on the bottom because milligram has to be cancelled. So 1 gram will be on the top. Okay. So milligram cancel, and then you will convert to moles. They have already given the molecular weight. So it will be, you will have 28.5 gram over 1 mole because this is the molar mass, you know. And then you multiply by the Avogadro's number. That is 6.022 10 to the power 23 molecules over 1 mole. So what exactly you have to understand and gain the expertise how to convert one unit to another? You should do it in one step. It is possible to do individual steps separately, but always it's become complicated. So if you put all the numbers on the top, 45.8 multiplied by 6.022 10 to the power 23. If you are putting in calculator, put a parenthesis or else it will be difficult. So it will be 10 to the power 3, 28.5. So if you calculate, it will be coming to around, I will say 9.83 10 to the power 20 C2H4 molecules. Okay. So if you follow the technique, what we discussed in chapter 2 and 3, they are very similar, only there is one more step in case of a compound, but the concept is exactly same. Now I will solve question number 51. Okay. So in this case, there are oxygen atoms. That is your starting point. How many oxygen atom is there in this molecule? Look at it. There are 3 oxygen atom in the entire molecule. So if you start with this one, 2.55, 10 to the power 24 oxygen atom, then first you convert to molecules. 3 oxygen atom is present in each molecule. So I will write 3 oxygen atom, and that is 1 molecule of N2O3. So if you divide by 3, because each molecule has 3 oxygen atoms, if you divide by 3, it will give you the number of molecules you needed to have this many oxygen atoms. Okay? And then they are talking about moles. So you know 1 mole substance contain always Avogadro's number of molecules. So it will be 6.022 10 to the power 23 molecules. So again, you look at it, atoms, atom cancel, molecule, molecule cancel. So your answer will be in moles. So it is 2.55 10 to the power 24 over 3 into 6.022 10 to the power 23. Again, you put parenthesis when you put it in calculator. Without parenthesis, it could be really, really difficult. Okay? So it will be coming to around, if you put it in calculator, it will be 1.41 moles of N2O3. So it means if you take that many moles of N2O3, it will contain, this is the number of oxygen atoms. So these are the kind of calculation you will be doing. And you know, as I said, many times people get confused when they are converting gram to mole, moles to molecule, molecules to atom. It needs a little bit of practice, okay, in a sense. So let me solve one more problem. Different type of problem. 57 and 58. If you look at it in this case, you know, magnesium bromide, MgBr2, and all this case in case of 58, there is a compound called FeSO4, and they are asking about ions, and both of them are ionic compound. Both of them are ionic compound. And I said ionic compound, if dissolved in water, they expect it to produce cation and anion. Normally, non-metal will produce anion, non-metal, and this is metal. And in this case, they are asking about the anions. Anions will be produced by bromine. In this case, they talked about iron 2 ions, and this is the metallic part. So instead of trying to tell you the number of atoms, rather they are talking about ions, and that is more specific and more useful when you calculate this kind of ions in ionic compound, because ionic compound produce cation and anion, they get separated. Molecular compound is not going to do that. So in that case, we don't talk about ions, rather we talk about the number of atoms of the individual element, not ions. So in this case, you look at it, you have 2.5 gram of MgBr2. You know, if you have to convert, first you have to convert to moles, and then you have to know 1 mole of magnesium is equal to how much? Look at it, in this case, they have not given you the molecular weight, you have to calculate. So what is the molecular weight of magnesium bromide? Magnesium is 24.3 into 1 plus magnesium is 80 into 2. So if you look at it, what is the molecular weight of magnesium bromide? It is approximately 184.3. The molecular weight of, this is the molecular weight. 184.3 the molecular weight of, this is 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 the molecular weight of So you divide by the molecular weight. This is 184.3 grams Mgbr2. And then you convert to molecules. Avogadro's number, 1 mole is all equal to, so it is, sorry, 1 mole will be on the bottom. So, so this one will be Avogadro, you multiply by Avogadro's number. Molecules, okay? And not moles, molecules. And in one molecule, how many bromine atoms is there? 2. So there will be 2 bromide ion, 2 Br, 1 minus ion, 1 molecule. So look at it. In this case, we are talking about the bromine ion, not bromine atom. But if you look at it in the previous problem we solved, we are talking about here oxygen atom. Why? Oxygen is a non-metal that normally don't ionize. So obviously in that case, you will not be talking about ion, but you will be talking about ion since magnesium bromide is a non-metal. So now you look at it, gram cancel, mole cancel, and molecule cancel. So you get the answer in ions. So then you take 2.5 into 6.022, or everything on the top line, divide by, and then also multiplied by 2, because there is a 2 here. And it will be 184.3. So if you look at it, this one will be approximately 1.64, 10 to the power 22, bromine ion. Okay. So this is the way to calculate. Let me solve one more, and then we will I will say, let me do question number 53. It's very similar. You have hydrogen atom, you have to convert to C3H8. Actually, this is very similar to question number 51, so I won't do it. Rather, let me do, they are all same. Let me do 54. That is a little difficult. So in this case, actually, they are asking how many oxygen atom is there, and you start with the quantity of aluminum carbonate. Okay, so look at it. You start with 47.6 gram of aluminum carbonate. And where do you want to go? You want to go to number of oxygen atom. How many oxygen atom is there? Look at it, 3 into 3, 9. So 9 oxygen atom per molecule. Am I correct? In one molecule, you have 9. So first you will convert to moles. How do you convert to mole? So look at it, the molar mass is given 233.9. So 1 mole of Al2CO3 is equal to 233.9 gram of Al2CO3. And then multiply by the Avogadro's number. That will give you the number of molecules, because 1 mole always contain Avogadro's number of molecules. And then, look at it, gram cancel, and then mole cancel. Then you have to molecule to atoms. How many atoms? So you will have 9 oxygen atoms. So if you put all of them in calculator, all numbers on the top in one line, again I will tell you, put a parenthesis. Without parenthesis, it will be difficult for you. And then put a parenthesis on the denominator also, 233.9. So we are talking about 54. Yes. So it will come to approximately, 1.1. So it will come originally 11.1, 10 to the power 23. So it will be approximately 1.1, 10 to the power 24 oxygen atom. Okay. So this is the way, we are converting gram to moles, moles to molecules, and molecules to atoms. Unfortunately, we didn't have any problem where, we have asked for all number of atoms together. For example, here, we are asking only for number of oxygen atom. But some problems maybe they will be asking how many total atoms are there. So in that case, instead of counting 9, you will count the total atoms in that molecule. How many the total atoms is there? Look at it, 2 aluminum, 3 carbon, and 9 oxygen. So it will be 9 plus 3, 12 plus 14. So if you look at it, so if in a problem, instead of asking the number of atoms of a specific element, if they ask for the total number of atoms, these 9 will be replaced by 14. Then that will give you total atoms. All calculation will be same, but only the last step, if they ask that, in 47.6 gram of aluminum carbonate, how many total atoms are present, it doesn't matter whether it come from aluminum, carbon, or oxygen, total. So in that case, 9 will be replaced by 14. So after finishing the chapter 3, you should have a clear idea the conversion that we are talking about repeatedly, gram to mole, moles to molecule, molecules to atom. They are relatively similar, but there is a little bit of difference in case of a compound and element. I hope it is clear, practice, and if there is any confusion still, let me know.